Here in problem number 5, we have a researcher who is comparing hemoglobin A1C levels in two populations of individuals from different ethnic backgrounds. They find that the proportion of individuals considered diabetic, so proportion considered diabetic from Caucasian population is 0.28 with N is 180. And the proportion diabetic from the non-Caucasian population is 0.22 with sample size of N equal 98. We're computing a 90% confidence interval for the risk difference. So risk difference means difference in proportions. So we have two samples here. They're Caucasian and non-Caucasian. This is a dichotomous variable. Either you have diabetes or you do not have diabetes. And we're finding the confidence interval for the risk difference, which means P1 hat minus P2 hat. So difference of proportions, P1 minus P2. So the information we're given, the first sample proportion is 0.28. That's P1 hat. And the first sample size is 180. That's N1. And then the second sample proportion is 0.22. That's P2 hat. And then the second sample size is 98. That's N2. Now they didn't give us the successes because they gave us the sample proportions. If we had successes, we could compute these. So let's go to Excel. So we want the tab confidence interval for P1 minus P2 summary data because we don't have the actual data. We've got summary. So let's go ahead and fill in our information here. So our first group size was 180. So that's the same as what was there. Number of successes we don't have, so we delete that out. Sample proportion we did have for that first group, 0.28. And then the second sample size was 98. We did not have successes, so we need to delete that out. And then 0.22 was our sample proportion for the second group. Notice the directions say N and number of successes or sample proportion. So you'll either be given number of successes or sample proportion. We had the sample proportions. We want a 90% confidence interval here. So we need to change our 95 to 90. And then they tell us that the risk difference, that's P1 minus P2. Well, P1 hat minus P2 hat is 0.06. So P1 hat minus P2 hat. That's the risk difference is 0.06. So if they ask for the risk difference, that's what they're referring to. And the standard error, so that's the standard error of the sampling distribution for difference in proportions. The z-score that goes along with computing the margin of error, that's the half width of the confidence interval. And now we got our lower limit, negative 0.028. So our lower limit is negative 0.028. And our upper limit is 0.148. So what does this mean? This means that we are 90% confident that the true difference, true population difference actually, P1 minus P2 is between our lower limit of negative 0.028 and our upper limit of 0.148. So that's negative 2.8% and positive 14.8%. So to say that the P1 minus P2 is negative 0.028 is saying that the second proportion is greater than the first. So for repeated samples, repeated pairs of samples of sizes 180 and 98. This interval will contain the true difference in proportions P1 minus P2 90% of the time. So for 90% of those pairs of samples. Now, one last thing that I will mention is if you scroll down here, it gives us some other information. So we were asking about the risk difference, and then this is the lower limit and upper limit for P1 minus P2. But if they asked for the relative risk, then that confidence interval would be 0.880 to 1.842. And if they asked for the odds ratio, then that confidence interval would be 0.849 to 2.24. So be very careful, and you've got three possibilities there. Be very careful to select the appropriate confidence interval that's asked for.